Hi, everyone. Can, can you guys hear me? Yes. Welcome. My name is Sheila. I'm part of the marketing team from OpenxAI, and welcome to our second Developer AMA, a very special event organized by OpenxAI. We're live on Xspace and on YouTube. We're excited to dive into the future of AI infrastructure and generative AI and to explore how OpenxAI Studio simplifies building, scaling, and monetizing AI apps on a decentralized infrastructure. As part of OpenMesh's participation in the NVIDIA Inception program, we're excited to have a very special guest from NVIDIA today. So we've got three key segments today. First, our founder and product architect, Ashton, will share OpenxAI's vision, our journey, where we're heading, and some exciting news updates. Next, our very special guest, Hariharan Suresh, Senior Cloud and Generative AI Technologist at NVIDIA, will dive into NVIDIA's GenAI tools, cloud SDKs, and dev platforms. Then our DevRel expert, John, will showcase use cases and our OpenxAI Global Accelerator Program at AI startups, followed by lead engineer Sam with some XNode Studio V5 updates. Please drop your questions in the chat and we'll tackle them during the AMA segment at the end. Okay, so let's get started. Let's welcome our OpenxAI founder, Ashton.
Hey everyone, if someone can give me a thumbs up if you guys can hear me. All right, okay, cool. Hi, my name is Ashton. I'm the founder and product architect of OpenxAI. Today we have really exciting some insights and also showcase some product. We have a special guest as well from NVIDIA. So we're excited to be part of NVIDIA Inception program. So I've got a couple of slides I will share with you in a second. So today is very important to us, especially because this is our second developer AMA. I'm going to share my screen and please let me know if you can see my screen. Yeah, I'm hoping you guys can see my screen. So I wanted to talk a little bit more beyond the technology, like more philosophical side. Like to me and most of you definitely agree that AI is one of the most powerful technology that we invented and created. But the big question to all of us, like who owns the AI today? So the answer is quite straightforward. Few corporations currently control the AI. Not only the AI as a technology, but also they are in a big race. If you look at like large open source AI ecosystems like Hugging Face, also private, even though they have a lot of open source tools, a lot of things are controlled by a private company and a private entity. So to me, AI more like a political right now, because it's a West versus East sometimes. If you really think about AI as a tool, as a technology, as a innovation, it's often it looks like a modern version of the Ark of the Covenant. Whoever has that access to the best AI technologies have the influence and the power. That's why I think a lot of corporations, a lot of governments are pushing for the AI. So if you really take a step back and think about AI concentration, these 4 to 5 companies, not only they control the AI, but they also have the largest a data custodian capabilities. They control most of the world data, and they have the largest data centers. So data centers to me more like the brain. Data custody is for me more like knowledge, and they also happen to have the AI capabilities, AI resources, and also the AI talent, all concentrated in a single a kind of a small group of people, and we're supposed to trust them. I mean, history has shown over and over again when you give them so much power and accountability and responsibility, we often make a lot of mistakes. So I think, to me, how AI is being centralized and controlled and given to a small group of people is the same thing what financial markets collapsed in 2008. Uh, Back in the days, 2008, you have a small group of large hedge funds and large banks. They had a control to derivatives market and MBS. So these financial markets, didn't have much regulatory oversight. Therefore, they did whatever they want to do, extract the value out of the ecosystem, financial markets. That's what led to financial market collapse. And I see we have the same kind of a situation. I don't know if you guys are familiar with the new big beautiful bill from Trump. It's basically state that a small group of companies, the companies that you see on the screen, they have a full autonomy when it's come to regulations. They have a lot of freedom. It's no longer state level regulatory oversight. It's more like federal, which is kind of a risky. It's the same thing during the financial collapse. Only like a small group of people managed to oversight and regulate themselves, right? So, and the challenge today, AI has a lot more impact in the world compared to like a financial markets. So we have to be very mindful about that. So this is where I kind of say this is a perfect combination for disaster. It's a bit scary compared to financial markets. And now I want to touch base a little bit about protocols, right? The protocols that kind of a change how society has evolved in terms of adopting technology. So internet protocol used to be like a military protocol, which is only access to a small group of people, and then it's opened up to public, and it became a big change for how we communicate, how we do conduct business, and etc. And Ethereum as another protocol enables smart contracts. As a decentralized supercomputer, you can actually create smart contracts, and you can do interact with peer-to-peer without having a middleman or a company. So I think I see OpenxAI, we try to do similar kind of innovation. So OpenxAI is a permissionless AI protocol. It's similar like IPFS or Filecoin. So Filecoin and IPFS, you can host your files, like a static files, like image. With OpenxAI case, you can do compute workloads and completely permissionless way. You don't have to register as no KYC. And instead of hosting your AI models or training AI models on these centralized cloud, you can use decentralized cloud and decentralized infrastructure. The other aspect, instead of using like a company or maybe bank account, we leverage smart contracts to achieve that. So that's OpenxAI, the permissionless AI protocol. We have some demos. Obviously, we can showcase how the protocol is operate and what are the use cases and etc. So the project itself, we started a few months ago, but the whole infrastructure we've been building for the last 4 years. Just to give you a bit of a background, so I got into Web3 in 2015. One of the project that I worked and be part of, it was Phantom or Sonic now. It was L1 chain. So I worked with Phantom and Phantom Sonic Labs, now they call it, for over 2 years between 2018 to 2019. And then after that, I started OpenMesh. OpenMesh is a decentralized cloud, similar like AWS of Web3. So OpenxAI is built on top of OpenMesh network. So consider OpenMesh is a decentralized cloud, and then OpenxAI is the AI protocol on top. So if you look at evolution of the AI industry, I see like really three to four buckets. everybody familiar with AI space today, most of AI services are centralized and proprietary. So these are closed source AI technologies. And then you see open source evolution. Like 3 to 5 years ago, we see a lot of boom in the AI, open source AI models and open source AI tools. And then in the Web3 space, we have something called a decentralized AI, right? To me, decentralized AI kind of open source technologies are managed by a community, and maybe it has a token for a governance purpose or speculation mostly. So, and the evolution, the next iteration or the next evolution of AI industry will be permissionless AI. So what's the difference between decentralized AI and permissionless AI? So think about very permissionless systems today, like Bitcoin is as a great example. So in order to access Bitcoin network, you don't need to get permission from anybody. You can access Bitcoin network by simply connecting your wallet to access. If you want to transfer Bitcoin from your wallet to someone else, you can do that without a middleman. You can do that completely without having a permission in a trustless way. So OpenxAI enable that for whether if you're an AI developer or AI founder, you'll be able to launch your AI service, AI agent, or AI company without a middleman. So we're going to do some demos how you can accomplish that very quickly. So this is what I was talking about, and I want to before I show you a demo, I want to take a step back and showcase like where the AI industry is evolving as a large shift towards to like S curve. So a few years ago, we had this massive hype in the AI space, especially introduction with ChatGPT. Now that hype is over. Therefore, what that means is going through a S curve. So if we have, let's say, some sort of a slowdown in financial markets and economic growth, what will happen is a lot of businesses, a lot of startups, enterprises, they will be looking for more efficient way to get things done. So if you have 10 teams doing some business tasks, and if you can replace that 10 team with some sort of AI innovation, a lot of businesses will look into that. So what I'm thinking, and also based on our research, we see, especially during an economic slowdown worldwide, we'll be able to see some good adoption in the AI space, right? So a lot of people will be looking to those AI services, and I think this is where the real growth will happen in the coming months and coming years. And the other thing, when you think about S curve, usually when you go through S curve, the cost has to come down significantly, because today AI, if you look at whether it's AI SaaS products or AI training, it's kind of a limited to a small group of people relative to the rest of the world. If you have to spend, let's say, $1,000 per year accessing like a chatbot, that's not affordable for a lot of regions, right? And if you want to launch your AI company, if you want to set up an AI infrastructure, training and hosting costs can be significantly high. So there are a lot of barriers for a lot of regions to go from 0 to 1. So here it's a benchmark test that we did in order to run, let's say, DeepSeek for 12 months compared to like a traditional cloud. What does that look like from a cost perspective? That's which is, I think, is important. So bringing the cost down significantly, like up to 80%, it helps entrepreneurs and engineers to build things and experiment things faster without committing significant amount of capital. So, and then, like I mentioned, majority of people who are wanting to get into the AI space or in the AI space that they wanted to build are non-coders. Then specialized developers and the talented people, this pool is very, very small. That's why at OpenxAI, we thought like we focus on no code, low code solution. So if you want to launch your AI agent or AI services very quickly, you can do that without even knowing the code or having a technical expertise. Thing about the permissionless aspect, it doesn't matter where you are in terms of your region, location, whether you have any geopolitical, let's say, resistance or geopolitical, some sort of restrictions. Because imagine if you are in Iran or North Korea, you won't be able to access like traditional Web3 services like ChatGTP. There are like geopolitical restrictions based on where you are and who you are. So the cool thing about permissionless aspect or permissionless, the property of a permissionless, the protocol itself cannot margin or cannot stop anyone using the protocol. So this is the one benchmark that we did comparing make this protocol available to anybody. So this is another a benchmark that we did in terms of censorship resistant. Is a very, very important aspects when it's come to permissionless and trustless parameters. The other important thing I think is a very big topic is the privacy. So when you, let's say, start utilizing a chatbot that managed by a private company like a ChatGTP or maybe Grok, when you're interacting with the chatbot, it collects your data and the data itself stays within the company. It's like when you upload your photos to Instagram and they manage all your data, they control, they keep your data. So the same way it goes to the AI industry as well. The challenge with this, we don't know what they are doing with the data. With OpenxAI, what we try to do, we help the end user manage the whole infrastructure, which means since you manage the infrastructure, I'll explain to you how it works. But since you have the infrastructure fully controlled by the user, same way if you use your hardware wallet to store your, let's say, your crypto, you control your crypto. So we apply the same principle with the OpenxAI when you launch your AI service or AI agent or AI company. The entire infrastructure, all the way from application layer to entire infrastructure stack, is connected to your wallet, and no one is controlling it, and it's wrapped in a smart contract, and therefore you ultimately control the data going in and also data coming out from the model, which is very, very important. So here's an example of like what's the comparison of OpenxAI to other services, whether it's a Hugging Face or a virtuals. For me, the most important thing is having the trustless and permissionless aspect is very important. And the other thing is having a functional product. A lot of no disrespect to our my colleagues in the decentralized space, but often the marketing go ahead in time and you don't have a product, it's just basically a hype. What we focus on actually talking to real users and understanding their pain points and build a really functional product. So I wanted to give you a really good example of how we extract that pain points to build a technology. So this example, I want to skip that quickly to go to that example, because that's very important to a lot of people. If you think about like launching your AI company or AI services, today, so this is the stack. So I think I don't have that slide here, but let me explain. So this particular example, so we have interviewed and we have spoken to a couple of AI startups, especially as the AI startup founders. So one particular example, so these startup based out of Sydney, Australia, and I'm myself based out of Sydney, Australia. So these two founders found a chatbot specialized in universities. So think like a ChatGPT for Australian universities. So the business model for this startup is you can ask 100 questions, and you when you ask more than 100 questions, you have to pay $10 per month. And when we ask these individuals, like these founders, their journey. So it's not about building the technology. Like, in order for them to like charge from end customers, so you need to somehow integrate a credit card payment system, right? In order to charge from customers. In order to collect the payments from the credit card payment system, you need to have a bank account. In order to have a bank account, you need to have a company. So in order to have a company, you need to work with lawyers. So before even launching your product, before even launching your startup, you have to do a lot of things in order to go from 0 to 1. And according to our research, like typically, if you want to start a company in Australia, you'll have to spend between $5,000 to $20,000 to setting up your corporation and bank accounts and etc. And imagine if you are from a regions that not necessarily have a bank account, because if you look at in the world, like more than 2 billion, there's unbanked more than 2 billion people around the world. They don't even have a bank account. They cannot even open a bank account. So how could you start your AI company and being able to collect payments and have build a business? So that these are big pain points that we found. So we thought, instead of using, let's say, traditional bank account and traditional infrastructure, why don't you use a wallet, right? So you'll be able to collect payments in crypto, whether it's Ethereum or stable coins, and you can receive directly payments to your wallet. And the other cool thing is you can launch your AI company in under like 10 minutes. Our target is about 5 minutes, but let's call it 10 minutes. It doesn't matter where you are, you'll be able to launch it quickly. So instead of having a company, use a smart contract. If you want to protect your intellectual property, have a smart contract that wrap your data and infrastructure, because that's pretty much your IP. Instead of having a bank account, like I mentioned, you can have your wallet, either one wallet or multiple wallets. So now I'm going to do a quick demo. And as a developer or a startup founder, how do you launch your AI company under 5 minutes? So, so here's our website, openxai.org. That's the domain name. Here you can find a lot of information. We also have a really cool side-by-side comparison to how we see AI today and how AI should evolve in the future, especially for those who are interested in benchmarking pricing and privacy. There's a table as well. It's all up to date with the data. So let me jump into the core platform. In a core platform, it's a completely Web3 console. You connect your wallet. There's no registration. There's no KYC. First of all, here you have the App Store. In the App Store, you have very most popular foundational LLMs or any open source models, similar like Hugging Face. So you pick your model and you pick your version, which version you want to deploy. And then here is what infrastructure you want to deploy into. So at OpenMesh, since we are OpenMesh Cloud, we have a lots of GPU supply. So that's why we give that for free for people to test. However, if you want to compare pricing, we have a great tool that we developed. We call it Skyscanner for GPU or Booking.com for GPU. So what it does, it scans real time unused GPUs and compute. It's going to give you a list based on based on the location and the price. So you'll be able to choose a server that is cheaper instead of spending like maybe $1,000 on AWS or Google Cloud. So these resources, so these nodes are coming from OpenMesh. So we'd love to work with decentralized cloud providers like Aether and maybe Akash to provide more compute. So these are nodes that we have across different regions, and these are the supply that we have. And then, as you can see, there are a bunch of servers are available in our database, around 600 pages worth. So you have a lot of supply. So you go to the App Store, you choose your model, choose your infrastructure. In this particular case, I will choose OpenMesh. You choose OpenMesh. And the third step is the tokenization. The example which I gave you before, the two startup founders from Australia who wants to build their ChatGTP for universities. If they come here, if they choose something like this, ERC 4337 ERC wrapper, what it allow you to do, allow you to create your bank account, which is the wallet, and have your subscription, so you can provide a peer-to-peer AI services without a middleman. So what that means, I launch this AI service from my bedroom, and anyone can access the AI services without any restrictions. And if I were to charge from the end customer, I'll be able to charge from crypto, or I'll be able to do that by provisioning my smart contracts. Then I can charge whether it's a one-time off payment or it's an ongoing payment. It's all can be leveraged and done through smart contract. So in contrast, if you think about that $5,000 to $10,000 or $20,000 that you need to spend on lawyers and bank accounts and setting up a company, so all you're paying here is for a blockchain gas fee. If you want to launch your tokenization or monetization model on Ethereum, you'll be spending maybe $5 to $10 worth of gas fee. And we intend to launch on Base first. So if you launch on the Base chain, your gas fee will be under $1. Like you're able to do under 50 cents. So what that means is instead of spending $20,000 or $5,000 to go from 0 to 1, you'll be spending less than $1 to launch your AI company. Since this is a 3-step process, there's no code required. You can launch your AI services from anywhere in the world. The other cool thing is, since you're hosting on a decentralized cloud, not a centralized cloud, so no one can shut down your services. And you don't need permissions to start your AI company. And you manage the data, you control your business model, you control your bank. It's a beautiful design. So I'll wrap it up. And since we have a really cool updates with our engineers, and this is, by the way, version 4 of the studio. And version 5 is what we are launching very, very soon. Sam will give you more update. So now I would like to pass the mic back to Sheila and introduce Harry from Nvidia.
Thanks, Ashton. Just welcoming now a special segment with Harry, Senior Cloud and Generative AI Technologist from Nvidia. Over to you. To stay.
Hello.
Hi, Harry.
Hey, Ashton. Nice
How are you?
It's really good. Awesome.
So thank you, first of all,
Perfect.
thank you for supporting our ecosystem. We are also privileged to be part of the NVIDIA Inception program. So thank you for the support from your side.
That's awesome. And I really love working with OpenMesh. So the journey of OpenMesh is really great to see. Like I see XNode shaping up very well, and you're integrating with multiple AI fraternity and making things easy for the Web3 world. That's cool. Yeah.
Thank you. So I'll pass it to you. You can share your screen. Thank you.
Awesome. Great. Hope my screen is visible. Right. So today I'm going to talk about what NVIDIA is doing in the generative AI and agentic AI world. That's going to be my core presentation today. So uh, before getting into the details and specifics, just want to mention most of the people will think that NVIDIA is a hardware company, but to put it righteously, it's more a software company rather than a hardware company. The We build like a lot of open source solutions. We contribute to like massive open source toolings in the ecosystem to like get things out fast and quick to the GenAI fraternity. Right. So let's jump in like what we have built with GenAI. So to understand Nvidia's depth with software, I just want to like show you this stack. So if you see the bottom of the stack, like you can see the hardware, which is basically all GPUs, TPUs, as well as we are building CPU. So all those hardware will lie at the bottom, which is consumable through a data center or through cloud, hyperscalers, or through NVIDIA cloud partners or at edge. Uh, on top, there is a common layer like what we built through CUDA. So on this, then we also like started like building CUDA X libraries. So what we mean by that is, so we don't want every developer to like sweat it out, like write very specific application logics on top of CUDA. So we have like multiple different ecosystem work, something like you have data processing related work, you can like do automotive related applications, you have like quantum related work, weather forecasting or generative AI, agent AI. So all these stacks need a very different mechanism to like build solution stack on top of GPU and CPU. So with this CUDA X libraries, we are trying to like accelerate the total consumption with simplistic APIs, which is built on top of Python, C++, or Rust. So it can be like more API specific, and you can like write less boilerplate code and directly like get into the specifics of using GPU effectively. Right. So this dots, like what you're seeing in the graph, is the number of packages like what we got in the Nvidia's universe of software ecosystem. So we have like around like 4,000 plus software packages, and we have like multiple numerous frameworks, application frameworks, which can accelerate specific industrial verticals. So this graph represents the foundation layer, which can speed up data processing, which can optimize and deploy generative AI solution stacks. All the dots are the unique softwares, and the lines are the dependencies which are associated with it. So we have like 4,000 plus unique software packages when we put that out in a graph. Right. Let's now talk about GenAI, just very hot topic for the past couple of years. What we are seeing now is GenAI is not only going to be just text. Like we are seeing multiple different forms of input. We are seeing even brainwaves, amino acids, multimodality, speech, text. All this kinds of different information is like fed through the models. Then the decoders can like perform efficient, and it can like give us very unique information out of what we want to like learn from the data. Then most of the organizations nowadays are like having like three stages of adoption of generative AI as well as agentic AI. The first one is like less customization. So you have a chat GPT OpenAI endpoint or a reasoning model endpoint, which is directly customized, which is directly integrated within the downstream applications. Then the next level, what we're seeing is for advanced use cases, like we are seeing a bit of fine tuning in their own business data. Then the third level is extensive customization or even like training models from scratch. So these are the three layers like what we usually see. Uh, so if you see, if you put that in perspective in a workflow, these are the different stages like we broadly like see, which are data preparation stages, training and customization stages, and consumption or deployment stages. Uh, I'll be talking about this in specifics going forward. So let's now talk about inference first before going into fine tuning or customization of generative AI models. So predominantly, like you have like hundreds of checkpoints available in Hugging Face, which is like solving very different problems. So what Nvidia does is like we basically like curate all the open source models, which is like very specifically like famous or useful for the open source fraternity. We make that as a container. So once we make that as a container, it is easier to like consume, deploy, and scale or shrink. So that's the need of Nvidia inference microservices. So with this form, what happens is you can like deploy this locally in any infrastructure. You need not like go for a managed infrastructure or a serverless form of consumption. So this is going to be purely a Docker container with different forms of deployments, what you can need for your business cases. So, and you also pack this with the industry standard API so that you need not like build and package all these open weights and open parameters for consumption. Then, if you have domain specific code or industry or fine tuning related use cases, then we can also like put that in. Out of it, like what you're trying to achieve here is like we are trying to like improve your throughput and minimize your latency. And whatever GPUs like you are going to like deploy this open source models on top, we are going to like tune that for utmost efficiency and accuracy. So that's the whole point of building a NIM. Just to like give you a bit of technical aspects under the hood, what's happening. So you can see that this is the 10,000 feet view of like what a NIM is. So we basically like use Hettiarachi LLM package, software package, to like do like things like deep neural network fine tuning or linear algebra related optimizations or in-flight batching kind of capabilities when you are like doing an inference on a large scale GenAI model. Then based upon the choice of GPUs what you're using, can be like A100s, H100s, or B200s, H200s. We basically optimize these models for the choice and generation of GPU you are operating on top of it. Then if you are like using like a large model like DeepSeek or reasoning models to scale, then you can also we also optimize that for multi GPU deployment or multi node deployment. So these are the nitty gritty things like we do under the hood when we are like building them. Then for consumption side, you can see the left side, like we integrate that with Kubernetes, we integrate that with uh, GPU operators and network operators to like scale it. Then under the hood, whatever Python operations and CUDA operations, we efficiently manage that with the Triton inference server as well. So this is the overall packaging of a NIM, which is going to like run inferences efficiently. Then this is an example of like running a Llama 3 AB instruct model on various GPU architectures. So here you can see that you have like four parameters which you can like optimize for. You can choose a choice of GPU. You can see the number of GPUs like required for running that model. Then you can say that like you want to optimize that for throughput or optimize that for latency or you want to like a balanced endpoint. Then finally, accuracy matters a lot. So you can choose between the kind of precision which you want to like run that model with. So these are the aspects which you can like tune and run that inference engine locally. So these are the engineering effort goes behind like running this kind of inferences at large scale. And this is an example of running a Llama 370B instruct model, which will have different number of GPUs and optimization profiling, so that that specific profile will get loaded into your GPU when you're running that container. Right. So we just like touched upon a GenAI model aspect. Then let's talk about the hot topic now, like which is agentic and reasoning. So how agentic AI and reasoning is going to like actually like solve a lot of problems. So why first we need to think about we need to take a step back and think about like why we need agents and why we need reasoning. So if you are going to like use a model as this, then what's going to like happen? You'll have tough times to like do answer validation, or if your questions are like complex and ambiguous, then the model need to like think about it and it has to like reason back to you and clarify certain questions. Then very important feature is like our thought process can like change. Humans thought process or the business flow thought process can change. So the system needs to like handle ambiguity and dynamically adapt to the situation. So for example, if a problem is like being like thought through by the inference engine, then the system may encounter a new information. So it has to like completely redefine the reasoning process, and it has to completely like improve the retrieval process so that the answer synthesis can be like very specific and meaningful. So for these reasons, we are like working at reasoning models. So Nvidia launched our own reasoning models by fine tuning llama grade models. So we launched three models, which is in the name of llama nemotron family. So this empowers AI agents to tackle complex challenges and adapt to change. So uh, these three sizes will ensure the right fit for any application for delivering optimal performances across systems. So we are looking at highest accuracy for agentic reasoning as well as non-reasoning. So this same endpoint can like help you to achieve both reasoning and non-reasoning promptings. So as well as like we can also like see we can like hit like higher throughput versus leading open reasoning models out there. Right. So just want to like shed some light on like how this flow happens, right? So we start with Llama for its internet scale knowledge and popularity among organizations. Then first thing what we do is we prune the model, reduce its size so that we can reduce the latency and increase the throughput. So both things will reduce the total cost of running an inference so that we can put the GenAI inferences in everybody's hands. Then the next stage, what you see here is knowledge distillation process. So you think about knowledge distillation as gaining knowledge from a teacher model who's like teaching students. So from the original Llama model, we increase the accuracy lost during like pruning, or we'll ensure the better responses by the knowledge distillation process. So once the pruning is like uh, done, and we do fine tuning on top of the prune model. So what this is going to like do is like we enhance the code capabilities of chat, mathematical understanding, coding, or instruction following capabilities, so that we can operate better on top of reasoning as well as non-reasoning. And Nvidia also like went through and create synthetic data from open models and public data sets to like do this fine tuning. And then we will also like add reasoning skills on top of it so that we can enhance the scientific thinking capability, math thinking capability, and coding thinking capability, so that we inherit the knowledge of public data set and increase the capability of reasoning. Then the model is further optimized through reinforcement learning capabilities to improve the alignment with users' intentions and expectations. So these are the stages of, or the recipe of making a reasoning model from available data sets or model weights. Right. So through this process of creating NIM, we don't only look at text generation. So we also like look at multiple different domains. Something like you have multi-modality capable models. You have like digital human avatar generating models. You have like simulation models. Something like if you have any route optimization problems, or any portfolio management problems, or you're looking at weather simulations. So we have models very specifically built for that domain as well. And you have retrieval models. So we work with every open source player out there in the market to like bring these models with utmost efficiency and performance. Right. So this is all about inference. I want to like share. Next, what I want to talk about is specifically the Nemo framework. Right. So previously I was talking about Nemo framework. A workflow for the entire Gen AI, right? So that is possible with Nemo framework. So you can like build generative AI or agentic AI applications at scale with Nemo. And this is open source as well. So you can see the total source code in GitHub, and you can also customize the total process under the hood. So let's take a look at very specific aspects of this framework. So the first thing which I want to talk about is everything with GenAI starts with data. Like You have now you have like data like in the forms of text. You have data in the forms of audio, video, images. So the data curation of Nemo helps you to like specifically curate the data, and the curated information can be like passed through the further stages. So you can like do deduplication. You can do like uh, classification within the data. Assume that like you're like specifically building a stem based model, so you need like specifically filter and heuristically check the data which is stem related. So all these capabilities are easily available with data curation. Then you have image processing pipelines, and you also have video processing pipelines, which I haven't like shown you here. Then the next capability which I want to specifically touch point is the support for tensor parallelism, pipeline parallelism, and expert parallelism. So when you're like going to like build models at large scale or fine-tune models at large scale, your framework has to be capable enough to like scale across multiple GPUs or multiple nodes, and it has to like efficiently use the compute, and it also have like reduce the memory consumption. So Nemo framework has all these capabilities built in, so that you need not like write a lot of complex code when you want to like train do a large scale pre-training or small scale fine tuning. Next, I want to touch upon some basic customization tooling support in Nemo. So customization in the sense I'm specifically talking about fine tuning options. So prompt engineering is just like telling the right information as question. So which is like pretty rudimentary and straightforward. Certain models may take it easy and operate on top of a proper prompt engineered question. The next stage will be like prompt learning. So uh, we can basically curate a very specific task and feed that task to the model, so that like we can like create a simple LSTM model on top of a large scale GenAI model, so that the LSTM model can act as a gate. Then the questions can be like formulated properly before passing that prompt back to the model itself, the GenAI model itself. Then you have advanced capabilities like parameter efficient fine tuning and full-fledged supervised fine tuning. So you all these different facets of customization is possible with Nemo framework. So you have all the recipes and scripts already built in. All you need to do is you need to get the data. You need to like curate it. Then once the curation is over, you can get those recipes with your base model and start going to like fine tune on top of that the model what you're choosing. Then the next one is like you have advanced techniques support with reinforcement learning. So this is going to like keep up your model with the latest information and feedback what you're like gathering from your business. So that's also that pipeline is also very much established. And also like you have support for direct preference optimization, proximity preference optimization. So those pipelines and advanced capabilities are also built in. So to get started to use Nemo, like you can actually like prototype that with GitHub, and also like you have Nvidia hosted APIs. So you can like go to build.nvidia.com. There you can like see and play around with all the APIs what we have already built with various different verticals. Then if you want to like build custom models from scratch, please take a look at the blogs, so that that's the starting point for you to like go and learn about doing things in a deeper space. Then yeah, this is what I was talking about. So please experience the models, then start prototyping with the APIs, then deploy the containers in your um, uh, local GPUs. Like example, like XNode, like what Ashton was uh, explaining to us. So this is going to be easy, so that you need not like directly use a managed service. Instead of that, you can control your entire pipeline of GenAI or agentic AI solutions. To apply for Inception program, you can actually like go to nvidia.com slash startups. So there you can like specifically see how Nvidia can help your startup journey. Also, like you can like take a look at our GDC toolkits, SDKs, and technical help by signing up. in developer.nvidia.com. So we curate all the latest information, what's happening in the world of GenAI and agentic AI there, so that you can like learn the latest and greatest things what we are like doing. And to reach out, please do ping. This is our emails, so you can actually reach out to us if you want to like take your startup and work with Nvidia. So this is the contacts. I'm flashing here emails. Please take a look at it. Thank you. Thanks for your time. I'm handing it back over to Sheila and Ashton. Yeah.
Thanks you so much, Harry. We are very thankful and grateful for the NVIDIA team and the Inception program for providing this very helpful and insights and updates. Thank you so much for being here tonight.
Thank you.
Thank you, and thanks. Now let's hear from John, DevRel lead. Thank you.
Hi guys, my name is John Forfar. I'm core contributor at OpenxAI and DevRel. So let me share my slides. Basically for this part of the presentation, we'll just be running through a quick demo of OpenxAI Studio and some of the apps that we've recently deployed over the past couple of months, which are pretty exciting. So first, I just wanted to talk about a big problem that we've found with a lot of developers. When they go to scale up their AI application, they have huge hurdles around cost. So when deploying an application that integrates with an AI model, what we found is they're paying quite a lot for traditional cloud hosting costs, either through AWS, Azure, Google, or they're paying a lot of API fees. So this is external API fees, for example, ChatGPT, Claude. They might integrate that into their application, and then they're paying a lot of different fees, monthly costs that just keep eating away at their startup business. And through OpenxAI and what we actually do with OpenxAI Studio, which I'll run into, is we dramatically cut that cost down, letting small business and startups save money on their AI costs. So let's jump into what OpenxAI Studio is. So it's a deployment manager. It allows you to deploy to bare metal providers across the world. And bare metal providers are people that operate data centers, but they're not as big as your top tier cloud providers, but they are doing an excellent job setting up reliable compute, storage, and bandwidth in an aircon data center in many places around the world, thousands of places. What OpenX Studio does, it lets you deploy straight onto bare metal. The whole studio is open source, so you can basically take this, run it locally. We also host it, so it just makes it easy for you to deploy. But you're in full control of everything from the code that deploys it all the way through the data that goes onto the bare metal server. So the resources we aggregate with OpenxAI Studio is 32 different cloud providers all around the world. So we can use up to 32 of these across 172 countries. The big benefits about OpenxAI Studio is there's no KYC, there's no credit cards that you have to sign up for when you're deploying your application. We can aggregate unused resources across different XNode servers around the world. And I'll show you on the studio what this looks like, but we're aggregating lots of bare metal servers. Just a little bit about behind the scenes of what OpenxAI Studio does. So it deploys XNode OS, and XNode OS is a fork of NixOS. So it's an open source Linux distribution. It has 16,000 developers on their discourse. It's got hundreds of thousands of app packages. So basically, you can deploy a huge combination of these to build whatever app you're building. The big thing for us is the whole thing is open source. There's traditional packages like Python and JavaScript. So if you want to install Next.js as a front end and Python as a back end, Postgres as a database, you can do all of this through the NixOS packages, which I'll move on to more in detail. And finally, the OpenxAI Studio App Store. We've got over 40 different open source LLM models that you can, like in a few clicks, deploy onto your XNode server. So let's just flick over to the demo. So I'll just change my share. And what I'll do, I'll share the OpenxAI Studio website. Let me load this up. Okay, so just going to the OpenxAI Studio website here. So this is at studio.openxai.org. Here you can see the resources that we're aggregating. So you can see here, we've got many bare metal providers all around the world. So Vultr, Equinix, just to name a few. And we're able to aggregate those resources so you can get the best price. And like I said before, it can be up to 80%, even 90% cheaper. The App Store is basically where you can deploy different AI models. And this is basically the back end of your application, the brains of your application if you're integrating AI. And the big bonus is all of this is running on the one bare metal XNode server. So it's very affordable, low latency. You can build really innovative applications, as I'll go into more in the near minute. The deployment section, we've set up 3 XNodes. So basically, these are pre-deployed. Now, I don't have a huge amount of time on this, but what I've done is I've deployed one like 20 minutes ago, and anyone can do this. They just go to Deploy AI App and select the model. So I'll do that now just to show you. So I'll share this tab. You should be able to see my AI models that I can deploy. I'm going to deploy DeepSeek R1, and this is the different parameter models of DeepSeek. So I'm going to select the smallest one for this, but you can select different ones as well. And then the Skyscanner interface. So basically, we're aggregating all of these resources that you can deploy to. So we let you sign up for an account for whatever bare metal provider you want. You enter the API key, and then you can deploy straight from this studio onto their data center. We'll just run with XNode now, which is one of those 3 pre-deployed servers. This is the monetization models that we're going to enable very soon. So I've got a slide at the end talking about the different business models around deploying AI apps when combined with Web3 business models. So I'll get into more detail at the end of the presentation. But yeah, you can select different Ethereum smart contract standards to deploy different types of business models for your AI app. And then you click deploy. Now I've got the deployment running. So what I'll do, I'll share that other screen. Give me a second. So share screen. Now this is the screen deployed. So yeah, you can see basically you get a URL that's deploying with your application. So I'll just enter in the details to log in and just do this quickly. So this is all provided on the Studio deployment page. Let's just log in. Okay, so you are logged in. Now, can you see my screen? Just, yeah, you should be able to see my screen. just confirming. Anyone in the chat, just let me know. You can see my screen. I've just loaded up a DeepSeek Open Web UI application. So all this is we're running a Llama with a DeepSeek R1 1.5 billion parameter LLM model running on the XNode, and then we've got Open Web UI package also installed. Can anyone else see the screen? Can't see. Okay. Okay, so I'll just see if I can share it in a different way. Okay, so let me try this. Apologies. Let's share on a different screen. Okay, so you should be able to see the web UI. I'm just going to quickly log in. Let me know if that works. Okay. And again, I'm just entering the credentials from the main page. Yep, you can see that. Great. And you've probably recognized this. I've run this demo in previous developer workshops. So yeah, I'll just ask a quick question about Nvidia CUDA in data centers. Now, this is a reasoning model. So basically, it'll spend a lot of time thinking about the question until it gets to the answer it deems correct, and then it gives you a clearly formatted, concise answer. So you can actually see this is a 1.5 billion parameter model running on XNode on a bare metal server. Yeah, I can see people are mentioning in the chat that they can read that and see. Great, that's fantastic. So basically, this is a very, very simple app. It's plugging in a LLM model with an Open Web UI front end, and it's just answering the question that I asked it. So cool. Yeah, people can see clearly. Great. This is not, you've probably used DeepSeek before, but basically you can run this yourself and run this on your own bare metal server. So you have complete control over the data, the server costs, the bandwidth costs, all of that on bare metal, which is basically wholesale rates for compute and storage, is very, very low. It's wholesale rates almost, so it's 80% cheaper than typical cloud providers. You can just imagine the different types of apps you can build. Okay, so I'll just flick back to my slides. So again, yeah, as you can see, we've got a whole bunch of different AI models that you can deploy, and it's a very cost-effective. Ashton did present earlier on, so basically you can go through the slides of what he presented, which talks about the costs and the benefits over other cloud deployers. Now, I just wanted to quickly run through some of the exciting and fun developer community that we have. Currently, we're running a OpenxAI Ideathon. So we're running that for 2 weeks. And basically, all you have to do is pitch your idea inside the community dev forum that we have. And what we'll do is pick the winner, and the best idea, we've got DevRels, we've got some developers and engineers that can help you build your application. So here's basically the post where you can go to it and actually talk about that. And let me just show you what it looks like. So here's the here's the community forum. Let me know if you can see this screen. So basically, this is the forum. Read through the different criteria of the Ideathon. Here's where you can pitch the actual idea. And we've got a whole bunch of replies, which is all the pitches. So you can see here, 12 people, I believe, has posted their ideas, which is pretty awesome. Someone wants to build Dreamweaver, which is pretty cool. So yeah, have a reply, go into the forum, get involved. Like I said, there's an ideathon running where we'll help you build it if you're successful and you're picked as a winner. The other aspects of the forum is obviously the AMA. So we do have an AMA towards the end of this call, where basically ask me anything. So if you do have any questions, make sure you go to the AMA in the forums. And then finally, this is the new announcement. So the OpenxAI Global Accelerator Program. So you can have a look at the terms here, but basically we've got a global accelerator program. It's designed to help innovative startup founders that want to build. So there's access to funding. There's GPU credits from bare metal providers. So we obviously have partnerships with bare metal providers around the world, and we can get you some GPU credits. So you might be able to get a month of GPU for free to help build your business idea. There's also an expert ecosystem in OpenxAI that can help you guide you on your project and what you're building. Okay, just going back to the slides. Now, the other thing I wanted to quickly run into, and I appreciate I'm running out of time, but yeah, Super Intelligence 2049 was an event that we ran at Token 2049 in Dubai on the 1st of May this year. So I'm just going to quickly show some videos. I won't show all the videos, but yeah, give me a second and I'll share my video. Now here's one, and just checking that the sound works, but I'll start playing now. So this is what we built.
Well, thank you, Crypto Kitty. Tremendous introduction, really tremendous. Look, I used to say Bitcoin was a scam, a disaster, probably invented by Hillary, but now I get it. It's freedom money, MAGA money. We are going to make Bitcoin huge again, huge. And under my second term, because the first was stolen, let's be honest, we're going to make Bitcoin great again. We're going to mine it in America. We're going to tax it lightly. And we're going to build a beautiful, beautiful Bitcoin vault in Fort Knox, right next to the gold Schiff keeps crying about. Bitcoin is American now. Sorry. Satoshi.
Hold on. I need to interrupt. Trump, I appreciate your enthusiasm, but you have absolutely no idea how distributed ledger technology works. Bitcoin was designed to be decentralized, no presidents, no borders, no Fort freaking Knox. You can't nationalize Bitcoin. That's like trying to trademark gravity.
Excuse me. You're the tech guy, okay? I'm the deal guy. I built hotels not knowing a thing about plumbing, and they flush beautifully. So you work on the code, I'll work on the brand. We're going to make Bitcoin huge, bigger than Google, bigger than gold, even bigger than Barron, and he's like 6'7" now.
You call yourself the deal guy, but what we've seen is textbook corruption. Your wife launches a coin, your insiders front run the announcement, and magically millions move right before your so-called crypto reserve pitch. That's not leadership, it's grift. Dressed in red, white, and bulged, Bitcoin survived Mt. Gox, China bans, and FTX. It'll survive you too.
Excuse me. You've been hiding for over a decade, Satoshi. No one knows who you are, what you are, or if you're even real. Could be a guy in his basement, could be China, could be Hillary for all we know. Meanwhile, I've been out here in the spotlight, on the stage, making Bitcoin huge, bigger than ever. Before you're the ghost of Bitcoin, I'm the muscle. I've got the audience, the power, and the presidential playlist. You're just a myth hiding behind a Githy repo.
Awesome. So that was our AI panel. So that was presented at the Superintelligence 2049 event in Dubai in May. Really, it was a showcase. So I showed you a deployable app template where we deployed DeepSeek R1 and then chatted to it with the front end. But this was something else that we built, and I can run through some of the code for the next example. But basically, as a developer, part of OpenxAI, you'll be able to build these innovative apps, do it at a very low cost, low latency, and you can combine Python, JavaScript, many different LLMs. So for example, that application used Llama 3 to actually generate the conversation between the different personas. We used an agent framework to define the personas of each person. For example, Toronto Pump or Satoshi. We're able to then use Sesame, which is a 1 billion parameter model. So we're running Llama 3.2 on the XNode, and we're also running a different model called Sesame for the voice cloning. And then what we're doing is basically converting from speech, text to speech to generate the voices. So it's pretty innovative that you can build applications putting all these different LLM and different AI models onto one XNode. You just join it together with, say, backend Python code and front-end JavaScript, Next.js, and you can build a whole cloud application that typically you'd be paying huge amounts of hosting costs with traditional cloud providers. You'll also be paying a whole bunch of different costs for external APIs like like ChatGPT or whatever you use to generate the AI app. And then also a database cost is another one. So we're running Postgres, which is an open source package on NixOS, the Linux distribution. So we are able to run all of these technologies on one XNode, very, very low cheap. You just have to be aware of what it is and how it all fits together, and we can teach you that in our developer workshops. We've also built the OpenxAI Studio, so you can one-click deploy these things. And this was, from what we can tell, the first AI panel ever, and we were able to run that in Dubai. So very innovative stuff. Now I'll just move on to the next example. Being aware of time, this is only 1 minute long. Let me know if you can hear it.
All right, so 20 seconds, try to keep up and down a little bit, yeah?
Should I speak English or any other language? Okay.
Sound works, awesome.
Hey, now I'm just want the AI agent try to mimic my Ukrainian accent, if you can recognize it through my English experience. But I'm
Now, I just wanted to walk you through what's happening here. So this is a crowd at an event. We're handing a microphone to the audience, and this person is asking the AI a question. This is in real time.
actually very happy to be here. Thank you so much for the invite. ASI, Fetch, and OpenxAI, amazing tech. It was a pleasure to see such amazing panel with these AI agents. My name is Ilya. I'm a founder of Synth and other AI agents that we do together with Fetch AI and ASI. Don't hesitate to come over and I'll tell you all the cool things about AI. It's a big pleasure to be here. Thank you so much. How this point, this voice has potential. I could order pizza, negotiate treaties, or just say mimic rocks. The possibilities are endless.
Now you can basically see how excited he got. So Mimic is using that Sesame model. It's listening through a microphone feed into the Next.js website. It's pulling that audio in. It's converting it to text, and then it's using Sesame to convert it back using his voice. So basically it took his question or statement that he made to Mimic, learning his voice in like under 10 seconds, and then it's like in real time answering his question in this format. So it's able to mimic a voice clone in real time. You can imagine the potential applications for lingual translation between different speakers that don't speak the same language in real time. So running all of this on a XNode is a whole bunch of possibilities. And I want you to go to the community forum and post your ideas there. And let me just head back to the slides. So how was it actually made? I'll just quickly show if I have enough time. Let me know if I don't. The GitHub. So I'll share that now. So what I'm going to show you is the GitHub code. So this is it here. Okay, great. Now you can see, yep. So this is basically the code. Like I said, there's Next.js, traditional Next.js application. So the developers in the audience, this is very basic stuff, deploying a Next.js app. You can use AI to help you build it. There's also a Python app running the backend. Again, this is just traditional Python code, so you can build a Python application. The real magic, and probably the hardest part, which is what we teach in the developer workshops, is how to actually deploy the configuration file onto XNode OS, which is the NixOS fork. Now, there might be some people familiar with cloud deployments. They might have used YAML files, maybe make files, or Ansible scripts to deploy infrastructure. Basically, it's similar to that. This is an open source Linux. It uses these Nix files to declare and basically deploy servers that are reproducible. So all the packages are signed, they're secure. You can't modify them unless you redeploy the application again. And this basically runs through. I'm not going to go through this in detail because I ran through it in the previous workshop video. If you just go to our YouTube, all of those demos I just showed you on YouTube are there as well. But yeah, basically this is the Mimic code. So you can see here Mimic, and then this is everything that's running. So all the Linux packages that are running on NixOS, how to deploy Llama, how to deploy the different LLM models, how to deploy Postgres, all of this open source. You're not paying an external provider to give you a database. Basically, you just do it yourself. And what we do at OpenxAI Studio is just make it really easy for you to deploy this in a couple of clicks. Let me just show you what we're actually going to release in the next, I'm not going to give a timeline, but in the next few weeks. So I'll just share my slides again. Sorry for flicking back between different slides. Now you should be able to see the OpenxAI App Store. Now I did show you the App Store of the current iteration. Basically, that's helping you deploy different LLM models. It's putting a front-end chatbot on there so you can engage and talk to it. And that's your secure chatbot. All data stays within that server. In the near future, we're deploying apps. So everything I just showed you, like the AI panel, the Mimic, we can actually do like specific apps that have voice clones of specific people. The beauty of this is we're going to enable people in the audience, people that are developers and want to build things, the ability to deploy apps onto this app store. We're also enabling, like it says on the left, different Web3 monetization strategies. So you can have a subscription model, so people would pay or stake tokens in order to subscribe to your application. They could be just paying per use. They might be a holder of a certain, say, smart contract or NFT. So there's a whole bunch of different models that we can enable, and it's really up to the developers how they want to monetize their application. All we're doing is making sure that you can deploy it on the cheapest hardware costs, wholesale, bare metal. We're giving you all the software tools. You can very quickly deploy and then customize the code to build your app. And all of this is deployed across 32 different cloud providers, or sorry, bare metal providers, data centers around the world. So if anyone blocks you, basically there's a way to just quickly, using NixOS, redeploy to another data center. It's very, there's no middleman to sort of block you. You can deploy your application code onto bare metal servers. We're building this app store. This is like an app store that we'll host. And what we're really trying to do is drive as much social engagement to your application. So we're adding likes, we're adding people that can, vote for your application. They can even stake and things like that towards your application. We'll be experimenting with different business models with the developers. And yeah, it's coming soon. So it's something to be excited about. Okay, this is my last slide. So basically, get in touch, be a part of the developer community. Now, I've given you a whole bunch of links to the different discourse forums, but also we have chats across WhatsApp, Telegram, and Discourse. So just scan that, take a screen grab of this, and join our developer community. Okay, so yeah, thanks for listening, and I'll hand back to Sheila. Thank you very much.
Thanks, John. Next, we have Sam, our engineering lead, who will share the latest on XNode Studio V5. Thank you.
Thank you so much, Sheila. Indeed, as John showed, we have a new platform upgrowing very soon, which not only has a new UI, but also some improvements at the base level. So here I have a more technical interface of what it looks like to manage an XNode, which, as mentioned before, is what we're deploying on. So first of all, it's important to understand that this NixOS, what we're based on, is unlike your normal operating system like Windows or macOS. Instead of having a base operating system which you install, and then based on that, installing applications on top, instead of that, you have, as John mentioned, this one configuration file, which describes your whole operating system, every application running in it, which means that your operating system only contains the application that you specify in here, which not only gives guarantees for security, unneeded attack vectors, but also minimizes the amount of storage for applications you're not using anymore. Similarly, you can easily remove applications from here and they will be removed from your system, as well as define multiple applications in one go. And when applying this change, this will happen in one atomic action, meaning you don't have an in-between state where you might have installed one package without another one. On top of that, this NixOS is declarative, which means you describe what applications you want and not how to install them. An example there would be, for example, for Ollama, which is a popular AI model runner. You can use this setting, which is Ollama acceleration, to enable GPU accelerated libraries. Normally, you would need your Ollama to be compiled with this functionality inside. But instead here, you enable this one setting. It figures out that it should compile this with a specific setting, as well as pulling in all the dependencies, such as CUDA libraries. So with this one change, you're able to very easily enable or configure the applications that's running. And on top of that, this is for your main XNode operating system. But for example, what we have in OpenxAI Studio is more of an application deployment. So in this case, for example, we have a VS Code server, which is an in-browser VS Code code editor. And similarly to describing your operating system, you can describe applications in a similar fashion. So in this case, the only application we want is Open VS Code Server. So we enable it. And in this case, one of the new features is we disabled the connection built into VS Code Server ourselves, because we now have our own authentication framework. So here we have a domain, which I own, which is test.xnode.podmans.com. And here I can not only define that it should expose my VS Code app to the entire world, but it also restricts access to just this Ethereum wallet. So when I go to the website, first, similar to your CAPTCHA, will be redirected into this interface where I'm supposed to connect my wallet to authenticate that I actually have access to this application. In this case, the wallet signing is on my mobile phone, so you won't see it. And that gives me access. But if you try to access this application, you get into a similar page, but logging in with any other wallet, of course, will not grant you access. This is one of the improvements, which, for example, allows us to get rid of the current automated credential generation. So instead of having to log in with your email and password, it can do it automated based on the demo XNode you're reserving. So either based on IP address or based on your wallet collect, like you just saw here. Other than that, one of the advantages of NixOS is that updates are super easy. It can automatically decide which dependencies you have, which in this case are GitHub repositories of applications you are running. Similarly, for any applications you have. And basically checking all these apps and then clicking the update button is all that's required. And it will automatically update all applications to the latest version, instead of for every application having to figure out how to update. Some of them might auto-update, others might need you to download the install script again, maybe even uninstall, which makes this server management a lot easier. On top of having security guarantees built into the XNode OS by default, this is one of the security benefits it provides you, because now it's so easy to manage your server. You can do it yourself, even with, for example, our no-code, low-code platform at OpenxAI Studio, meaning you do not need a technical developer or a DevOps or a sysadmin to do this for you, which of course is convenient that they take care of the technical complexity, but provides a major risk because they need the access to do their job. They have a lot of sensitive permissions into all of your applications, such as, for example, secrets. They can make unauthorized edits and perform malicious actions, which is, of course, a massive security issue. Hence why XNode gives certain security benefits. And on top of that, because of this NixOS configuration, makes it easier to develop for, as Nix guarantees that whatever you have on your local development will also be exactly the same as when you deploy it on the server. This also means that you don't have vendor lock-in like you currently have with hardware. If I'm hosted this on AWS and I decide at any point that I buy a server at home and I want to migrate it, I can just copy this configuration. I can copy the file system state, and now I have an exact replica of that server running locally. And one of the things what we want to enable with XNode is also, of course, the developers building on top of it. So we have SDK for several languages, such as Rust, TypeScript, and React, which this front end you see is one of the examples of what you can make with the React SDK. And similarly is our OpenxAI Studio is also using the same React SDK. And similarly, you can also make your own front end in case you don't like this technical interface, but you also don't like our no-code, low-code solution. You can make your own interface based on this SDK, and it makes it a lot easier to develop on top of XNode. Now, this SDK is not the only thing you can put on top of XNode, because on top of this SDK, you can have more layers of managers on top of your XNode. For example, as John already mentioned, in the new version, we might have decentralized access control, meaning that your configuration access, such as editing what applications are running, might be restricted to an external data source, such as a blockchain permission. And similarly, you can do this for your full XNode, your operating system, but also just for one application. And similarly, you can also give access to one application under certain conditions, such as you have to provide staking, which allows you to way easier set up your own AI monetization framework. So you set up an AI server which integrates with XNode authentication. Based on the XNode authentication, we'll get access based on the people who are either paying a subscription fee or staking to your smart contract. And once they stop staking or once their subscription ends, then the access will automatically be revoked, making it a lot easier for you to set up your business with just focusing on the application and leaving the core technologies to OpenMesh. Now, this is a lot to go through, obviously. So in case you have any technical questions later, maybe you're not watching live, maybe you get a question later, or maybe you want to investigate, then I highly recommend you to reach out to me directly for any questions. So you can reach me by email, which also has the same QR code here. And of course, I'll also be available during the Q&A session we have right after this. Thank you so much.
Thanks for the update, Sam. That was great. All right, so it's time for the AMA. I'll add John and Ashton back in to answer all the questions, and we'll pin them to the screen.
So are we going to see questions on the app, or?
Oh, they're on the screen here. I can see Priyanshu has asked a question. I'll just read it.
Yeah, sure.
So
I can't see.
okay, I'll read it out.
Okay, go ahead.
Yeah. So what's one underrated or often overlooked aspect of building AI infrastructure that you think might not get enough attention in sessions like this, but is actually super critical when scaling applications? So what is one often overlooked aspect of building AI infrastructure? What I sort of mentioned in my talk, and I'll hand it over to the others to answer as well after this, but building your application, the front-end server, the back-end server, and the AI LLM model, having that in a traditional cloud means you're deploying it in potentially three different data centers. So there's huge latency, huge cost. There's a bunch of cloud engineering work to do to be able to deploy that in the one data center. Sometimes it might not have the specific version of Postgres or PG Vector or whatever you want to run. So you have to spend money on Pinecone to get your, say, vector database running. Traditional apps and the way you do it on traditional cloud can be very expensive. With XNode, like I said, just configure that one Nix file. You can actually deploy the whole thing on a super powerful wholesale rate bare metal server. And like I demonstrated with Mimic and the AI panel, very low latency. Like Mimic can voice clone and then repeat the person's voice back to them in its Q&A. So it's amazing what you can do when you're just building on the one XNode and hosting it all within your own infrastructure. You're not using disparate servers that are deployed across different data centers and different cloud providers. I'll hand it over to the others.
The only thing I could add, if you wanted to validate your use case, don't worry too much about scaling. Just get the quick and dirty, and have someone good in your team, especially like who can understand scaling, because scaling can be obviously whether it's a load balancing or focusing on like how you serve your customers, but try to get your product market fit first before you're thinking of scaling. So short answer, do whatever you can to actually validate your users and users pain points. So you have a technology that you're supposed to scale, because a lot of startups we see, they scale because they want to scale, but without validating.
Yeah, I agree with Ashton there. It's usually scaling is one of those topics which people overcomplicate. People underestimate how powerful just a single server can be and how much complexity that takes away, which also, of course, has benefits in relation to security. If you only have a single machine, then that's a very easier to manage environment compared to having a application which might run on one of 1,000 machines. Similarly, one of the things we're looking at for OpenMesh is mainly an OpenxAI Studio also, is a no vendor lock-in. So many of these cloud providers have their own scaling solutions. One of the few, one which is shared across of them is Kubernetes, which is why it gained such much popularity. But with OpenMesh, what we want is you to be able to have a shared interface to all these hardware providers through a single dashboard, which could be OpenxAI Studio, which doesn't matter anymore who provides you the hardware, but you can manage them all in the same way. And similarly for scaling, you can decide your own way how to scale servers, if that's using, for example, Kubernetes kind of approach, or if that's a more rigid, hiring a certain server extra once you reach a certain GPU threshold.
Yeah, I'll just add to that as well. Like the other part of scaling is the costs. So if you imagine deploying a very complicated scalable cloud app across 20 different servers, it's very expensive. I've heard of different AI app developers spending like over 20,000 US dollars per month. You can dramatically bring that cost down if you build the application very in a smart way. If you control the operating system that runs on the bare metal hardware, you can, and then use, say, NixOS fork, the XNode OS, to very specifically, declare what application packages are running, what databases are running using that Nix file. You can really optimize it and make your application more efficient. So it's running on, say, one XNode, which is a huge cost saving. We sort of lost the way where you deploy the app and it's scalable across 20 different servers. There's load balancers everywhere. There's like servers spread out across the world, and you're paying $20,000 a month for your cloud bill, and your startup goes out of business. So the other aspect of scalability is the costs, and that's what you can drive down and actually make your startup more sustainable. Okay, I'll move on to the next question. Okay, so this one's from Akshay. So let's see what he says. So basically, he's our OpenxAI India ambassador. So he's put his question in the AMA. With decentralized AI gaining traction, especially through platforms like OpenxAI, how do you see traditional cloud infrastructure evolving to support distributed inference at scale? So, Sam, did you want to have a crack at answering that first?
Yeah, basically already also what you mentioned in the previous answer, OpenMesh with XNode technology, which is what OpenxAI is based on, basically allows us to aggregate hardware from a bunch of different sources and not really care about who provides this. Could be an individual, could be a large data center. So for this specifically, with such a layer on top, we're not really dependent on these traditional cloud providers in what functionality they offer, as we just run directly onto the hardware. The only advantages we see in, for example, decentralized AI, but in more general hardware like GPU sharing, a CPU has a bunch of security features built into it in the recent years. So you can securely share this with other people without having person renting it to you, having access to this data, which is a similar transition which we see currently for GPUs. So as GPUs are more recently to gain such traction, to have these massive data center GPUs, which AI, of course, a few years ago was much less common to have as a service. In this sense, now we see these hardware providers enabling more security features within these GPUs to be able to share them with other people, which I think is a really exciting movement. But in that sense, we're mostly dependent on the functionalities provided by the hardware, not so much as by the cloud providers.
Okay. So yeah, we're just moving on to our community forum. So like I said, join the community.openxai.org. This is our discourse forum, and we post everything, all updates, links into this forum. So please get involved. Currently, we've got 51 developers in the forum. So yeah, get involved. There's a lot of opportunities here, from different programs that we're running through to employment opportunities, to grants. So check it out, have a look at the forum, and you can learn more there. Now, in terms of questions for AMA, I'm just scrolling down here. So we've got another question. It's come from Connect365, is related to multi-use GPUs. Will future Nvidia GPUs offer dynamic modes or profiles that optimize performance for gaming AI and workloads? We don't have Harry on the call anymore, but yeah, we can certainly reach out to him and get you an answer for that.
One thing I did notice with the latest NVIDIA drivers, they do actually make a distinguishment between the gaming and productivity. So you do have separate drivers which have different optimizations for gaming and productivity. Hardware, there's no support for this. It's just a software change, but there is that would be an indication that they're indeed working on separating these two use cases with different optimizations.
Okay, so I'm just running through some of the questions. So with OpenxAI making decentralized AI infra real, do you think we'll see AI shift towards more modular plug-and-play services? And is currently cloud infra ready for that kind of shift? So this is a very exciting area. So modular decentralized AI infrastructure is something that's we've got something we're working on, especially at OpenMesh. So a lot of that technology, similar to XNode OS, can be deployed on a bare metal cloud server. You can deploy it locally on your own hardware, on your own computer with GPUs at home. It is, like I said, a fork of Linux, and it's the great thing about NixOS is it has so much driver and package support for all the different hardware types, especially for bare metal and server infrastructure, especially for GPU cards and AI infrastructure. I can pass on to Ashton or Sam to talk more about this shift that you're sort of seeing in the near future.
Yeah, I think if you look at a modular architecture, or let's call it like a microservices architecture, where you can build things and you can host things and you can deploy things, I see a future where you'll be able to kind of source like transformers and running applications and being able to plug things in, like a Lego blocks. But the issue now, a lot of centralized providers, because they follow their own type of a governance and business model and approaches, then it technically is not composable and interoperable with another provider, because they wanted to showcase whatever they have is what is the industry standard, right? So I think that's where the challenge is. But if you're going into more permissionless, more decentralized aspect, from there you can come up with like some community can come to consensus how to define, let's say, a transformer interoperability, right, between data sets. And also I think in the future we also need to come up with the good standards around MCP, which is kind of like a middleware between systems to talk to each other, especially if you think about agentic world of AI. I see like we're going to see some good progress, especially in the open source community, because the consensus, of course, different systems, they have to prioritize that first, right? So modular architecture, modular approach has to be there by default. Otherwise, there's no way to build things and connect things. From a corporate world, more centralized, it would be a closed ecosystems. The difference between those two worlds, centralized, more, let's say, closed ecosystem will have a lot of, I would say, quality, but community-driven projects may not have a good quality depending on where you look at. So we'll see how the future evolves. But one thing for sure, open source movement is most likely will put a lot of pressure on the centralized providers. And I think open source movement and open source communities will invent better and faster infrastructure and technologies.
Okay, thanks, Ashton. I think we're almost at 2 hours, so we're going to wrap it up. Thanks to the OpenxAI team, and especially our guests, Harry, and for Nvidia for this incredible session. A huge thank you to the audience for joining us. And if you're a dev, now's the time to try OpenxAI Studio. Follow us on OpenxAI and X for updates. I have also pinned to the chat links for OpenxAI Studio, our dev community forum, and Linktree with all our socials. Don't forget to follow and join. And thanks again, and see you all next time.
Thank you, everyone.
Bye.
Thanks,
Thank you.
guys.
Thanks, everyone.